Download this code and get free GPT-4o from codegive.com, link in the description below. Sure. Convolutional neural networks, CNNs, are a class of deep learning models that are particularly effective for tasks like image classification, object detection, and more. In this tutorial, we'll build a simple CNN from scratch using numpy, focusing on the fundamental concepts of convolution, pooling, and fully connected layers. Step 1, Understanding the CNN architecture. A typical CNN architecture consists of the following layers. 1. Convolutional layer, applies convolution operations to the input image. 2. Activation layer, applies a nonlinear activation function, like ReLU. 3. Pooling layer, reduces the spatial dimensions of the input representation. 4. Fully connected layer, connects every neuron in one layer to every neuron in the next layer. Step 2, Convolution operation. The convolution operation involves sliding a filter, or kernel, over the input image and computing the dot product at each position. Here's a simple implementation of the convolution operation in numpy. Step 3, Activation function. We typically use the ReLU, rectified linear unit, activation function, which is defined as \text ReLU, x, equals \max, 0, x, \. Here's how to implement it. Step 4, Pooling layer. Pooling reduces the dimensionality of the feature map. We'll implement max pooling, which selects the maximum value in a defined window. Step 5, Fully connected layer. In a fully connected layer, every neuron is connected to every neuron in the previous layer. We can implement this by taking the flattened output of the last pooling layer and applying weights. Step 6, Putting it all together. Let's create a simple CNN with one convolutional layer, one pooling layer, and one fully connected layer. Conclusion. This tutorial provided a basic overview of building a simple CNN from scratch using numpy. While this implementation is quite simplified, it captures the essential operations in a CNN. In practice, you would typically use a deep learning library like TensorFlow or PyTorch, which provide optimized and more complex implementations of CNNs. However, understanding the underlying operations helps in grasping how these frameworks operate.